Good morning, everyone. Today, inshallah, we will go through our course notes and we will make a quick revision about our final exam. This is me, I'm Dr. Omar, and I will be with you within the next within this revision and for the next half an hour or so. Of course, our course notes, references, you will find everything already exists on Canvas as usual, and you will be able to see most of our drills and our main points of this revision. Okay? I want you all to remember that in this revision we will go through class works, class work 1 and the class work 2, and it will give an overview about our module. Of course, everything that we studied together will be involved in the final exam. The final exam is supposed to cover the following I-laws. Number 1, remember, knowledge and understanding of functions. Number 2, knowledge and understanding of various methods used in evaluation of limits. Understanding the derivatives, main concepts, main formulas, the limit law, and all the fast derivative formulas that we did go through. Implicit function derivatives, of course, parametric derivatives, and so on. Okay? Application on derivative, which contains L'Hopital method, Taylor and Maclaurin expansions, and of course the investigation of various functions through the maximum, the minimum, the various types of asymptotes, either the vertical asymptote, the horizontal, or the inclined asymptotes, and then finally you will be able to graph your sketch or your function. Also, we will go through, or the final exam will cover understanding of definite integration or multi-derivative process with all ideas that involved in this topic. Going through also the evaluation by integration by parts, understanding of the concept of integration by substitution, how to use it, when to use it, how to go through it, all of this should be covered. Going also through the application of definite integration, mean value theorem, and the evaluation of area under the curve with respect to the axis of integration. Also, we are very lucky that we will go through numerical integration with this module, so you will be able to have an idea, just in case if you have not integrable function or unintegrable function, how to go through using two of the famous methods that's used to treat such definite integration, the trapezoidal and Simpson rules. Also, we will go through complex numbers. We will have a nice idea about complex number, how to simplify them, okay? Plus the Euler and Euler forms in order to manipulate a certain shape of a complex number. Finally, understanding and knowledge about algebra matrices, going through a solution of a system of equation, how to go through it and how to deal with it. I've already chosen some of the main and vital methods in dealing with system of equations, like the elimination method as an introduction, grammar method, and also going through the Gauss-Jordan technique in order to treat such system of equations. Remember, this is class work 1. This is the cover of our previous exam, confirmed with 10 questions, each one of them with 10 marks, and it's supposed to cover the first part of our module, which is related to types of functions, the sketches, limits, application derivative, and application on derivatives. This was class work 1. Remember. First of all, you will have a question like this, which is states it's required to find or to determine the domain, the range, and of course to give a quick sketch for such function, which is really very simple. In this part, you will have to review the main functions, the relation, the main forms related to those functions. Just please, if you have any problem, just go to the web that's dedicated for this part of our course, and you will have more information. If I want to treat this function or to go degree of the numerator and the denominator, they are almost the same. We will have to manipulate this form in order to get to our normal form. Remember, our normal form states that y minus v, which equal to k divided by x minus a. I will try to approach this normal form as possible. If you see we have y equal x plus 3 divided by x minus 2, you can do it either by making one division or just manipulate the denominator in order to be divisible by the denominator, and you will get our form. In a quick look, so it's very, very simple. All we have to do, as you know, we will subtract negative 2 and add positive 2 plus 3, which is divided by x minus 2 as the first step. The second step, try to isolate the denominator from the numerator, so it's going to be x minus 2 plus 5, all of them divided by x minus 2. Now, try to distribute the denominator on the common denominator, and you will end up having this form, y minus 1, which is going to equal to 5 divided by x minus 2. Simply, all we have to do is to divide x minus 2 divided by x minus 2, you will end up having 1, then plus the remainder, which is going to be 5 over x minus 2. Moving positive 1 from the right-hand side to the left-hand side, you will end up having this form. Once we have this form, now you can speculate the domain, speculate the range, and also you can give a quick sketch for this function. All we have to do is to determine, as you know from the study of our course, is to find a vertical asymptote. The vertical asymptote is obvious, which is at 2. So all we have to do is to go to positive 2, making a vertical asymptote. This is our vertical asymptote. And we will have another asymptote, which is in this case as a horizontal from the main form. So it's going to be at 1. So this is 1. And you will have a horizontal asymptote, which is going to affect actually on the range. Then the function will be, as long as you have k is positive, so you will be within the first quarter and the third quarter, as you can see. So this is the sketch required for this function. The domain is simply, it's going to be domain, it's going to be x belongs to R, except the point at which you have singularity within your domain, which is 2. Same way like going for the range, which is going to be y belongs to R, except positive 1. For the time being, reviewing such problems for you, it's going to be very, very simple. As we already did go through that, and you already remember the last part in the derivative portion of our module, which did go through how to sketch functions in more complicated manner. So this is going to be very, very obvious for you. In the final exam, you are supposed to have problems similar to those ones with all types that we did go through previously. Remember quadratic function. Please do remember, if we multiply this function by a negative value, what's going to happen? Remember, if we had, for example, a square root on the denominator, how it's going to affect your graph, okay? Start to think about that, okay? And please, if you have something not clear for you, please do review this part in our module. You will have 3 vids already uploaded on the YouTube, so you can go through them, and I think you will be in good shape. The second question that we did we have in our previous exam is the part covering the composite functions and the inverse function. Here I will go through the composite function, and please remember the inverse, how to get the inverse of a function. If you remember, you have to go just only 2 steps. The first of them is to get x in one side instead of y, then replace every x by y and every y by x. But remember, before you start your steps going through an inverse function, for an inverse function, you have to be sure that your function is a one-to-one function. That's every value of x has just one value of y and vice versa. get f comes g, it's really very simple. And also it's one of the steps that you will have to check through an inversion of a function. If you get f comes at f minus 1, you will end up having x, if you remember what I'm saying, okay? If I want to go through this function and get f comes at g, it's really very simple. All you have to do to get f as composite of g of x, what's really needed is to get f, replace every x in f of x by g of x. So the first step is to write the form of f of x, which is simply a bracket to the power of 2 minus x, and then insert g of x instead of x, like this. If you have, or if it's required for you to find the domain and range, it's not required. But if it's required to find the domain and range, first of all, or to determine the domain, first of all, try to find the domain for g of x. You will have to restrict the domain to the acceptable domain of g of x. Then make your substitution, and if there is an intersection, the overall domain will be the intersection that satisfies both g of x and the final form of f comes to g. So simply all we have to do is to replace every x by sine x squared, and this is gonna be like this: sine x squared to the power of 2 minus sine of x squared, and it can be written on this form: sine squared of x squared minus sine of x squared. In this way you will have your 5 marks for this part. For the second one, it's exactly almost the same. Start getting g as the composite of f of x, I'm sorry. So in this time, I will write first g of x, which states sine the argument, and take care that the argument is to the power of 2. All I have to do for the time being is to replace x and g of x by f of x. Here's f of x. So you will end up simply having sine of to the power of 2. Just take f of x and invert the main function, which is going to be x squared minus x. This is exactly what's required. Not saying this is the first f as a composite of g, and this is g as a composite of f. Of course, you will remark that f composite g of x doesn't equal to g as a composite of f of x. This is the full solution for this problem. You will have your 10 marks. I've already put 4 marks on the first form, 4 on the second form, and 2 on this statement for most of you for the grading for this problem. If for some students who got the domain and range, it's a normal thing. If you did something wrong, we can replace it. So this is mainly what was required in this question. Also, once more, if you have any problem related to this part, please do go watch the full videos covering this part and try to resolve these problems. You don't have to go through all the solved problems, but just pick 1 or 2, just make your hand, write it down, it will help you out, okay? The second part is talking about trigonometric functions, the representation of various types of functions, the proofs, and so on, blah, blah, blah. This part is really, very important. You are subject to one of these problems. Not exactly like this one, but who knows? You will have to go through them. Also, through the inverse trigonometric functions and the proofs related to it, you may be subject to one of these. If I want to remember some of the trigonometric relations and how to manipulate a form like this, it's really very simple if you remember. All I have to do is to try to figure out a way in order to break sine of 3x in order to come up to sine, just sine of x, which is simply can be done like this. Since sine 3 of x, which equal to a sine of x plus 2x, this is the first step. Start to memorize the various relations that connect sine alpha plus beta or So I think this is going to be cosine of x times sine 2x, then plus replace these quantities, so you will have sine of x times cosine of 2x. The second step, already we need sine of x. So, okay, wait, we have sine 2x, start to remember sine 2x, what's the value or the relation between sine 2 of x with respect to sine x. I need to see sine x. So simply we can replace sine 2x by 2 of sine x times cosine x. Remember that we still have cosine, so you will end up having cosine squared. In a similar manner, I have sine x, which is, I already know I need, and you have cosine 2x, which should be replaced by 3 laws if you remember. Cosine 2, cosine square x minus sine x, or 2 cosine square x minus 1, or 1 minus 2 sine x. I need sine x, so simply just try to replace it with 1 minus 2 of a sine square x. I think it's that form. Also, I need to get rid of cosine square, which is simply can be replaced by 1 minus sine square x. So simply we have 2 sine x, 1 minus sine square of x, plus same way like you still gonna have sine x minus 2 of a sine cubic x. We are in the right place. We start to see now sine x to the power of 3, which we list and this in the final answer. So all we have to do is to try to expand it and then gather the various terms. You have 2 sine x, and then you have sine x, which is simply gonna come up to 3 of sine x. Then you will have negative 2 sine cube, and you have negative 2 sine cube, so you will have negative 4 of sine cube of x, which equal to sine 3x. Voila, that's what's required. In most of the problems that's required to prove something, start to think about the left-hand side and how to make it go through to the right-hand side. Start thinking about the relations that will achieve what you are aiming for. Instead of having 3 of x, you just will have to first to restrict your laws to have sine x. One of the things that I want you to remember, you are allowed to have one paper, double-sided, A4 size, okay, using font about 12, and you can write about 12 BT, so you can write most of your laws if you like, but don't write any solved problems. It will be forbidden and taken from you in the exam, okay? This is clear. I've said it a lot of times. And also it was in the first paper that I saw you for the final exam, okay? Start, mainly, don't write everything, just write the relations that it looks vague for you, or you may forget. Don't put everything, you will lose space, so just pick the right ones. The other relations that you remember, like this one, sine square x is just 1 minus sine x. You already know that. You don't have to write it down, okay? This is for this part. Once more, if you have problems, you will have to review the main this problem, I have a lot of comments about this problem. And also, you will be subject to problems like this, dealing with logarithmic function, and on the other hand, if you have exponential functions. Remember, the first part that we did go through functions, we did go through linear functions, very, very simple for you, quadratic forms, rational functions, logarithmic functions, exponential functions, trigonometry, and the hypergeometric functions. And all of these knowledge, it has to be in your mind. Dealing with such a problem like this, I want you in all times to remember, if you're dealing with an exponential function, think about logarithmic functions, and vice versa. If you are dealing with logarithmic function, don't get away from using the link between exponential and the logarithmic function. First step, you can't use logarithmic form on this function. First of all, you will have to isolate the exponential function to be by itself. If you use logarithmic function on this form like this, you will have to remember the actual law of getting len A plus times B. So you have to separate them first. So the first step, simplest, the first step, start to isolate your exponential part. So we have 4 times e to the power of 2x plus 3, which equal to 8. Don't use the arithmetic function at the time being. Some of the students make a lot of mistakes in this part. First thing, start to get your exponential function by itself, so simply divide both sides by 4. So it's going to be e to the power of 2x plus 3, which is going to simply equal to 2. Once you isolated your exponential function, it will be simpler to use logarithmetic. Start taking logarithmetic or len for both sides. Take len for both sides. Once you do, you use len for both sides, you will have len of e to the power of 2x plus 3, which is simply going to equal to len 2. Now we can take advantage of getting the power of this function to be outside. So simply it's going to be 2x plus 3 times len e, which is going to equal to len 2. You don't have to write this one, as you know, len e equal to 1. Now you get your unknown simply, which is 2x plus 3 equal len 2. You can do 2x equal to len 2 minus 3, and you will end up having x equal len 2 minus 3 divided by 2. This is the main steps. If you like to take logarithmetic function from the first step, it's okay, but you have to manage it well. If you take len for both sides, so it's going to be len 4 times e to the power of 2x plus 3. Remember, all this side, it has the arithmetic function in it, which is going to equal to len 8. So first of all, before moving your power, you will have to separate these two parts. So it should be done like this. Len 4 plus len of e to the power of 2x plus 3, which is going to equal to len 8 on the other side. Then start to move len 4 to the other side. So you will have 2x plus 3, which is simply going to equal to len 8 minus len 4. You can take advantage from the arithmetic function, having len a minus len b, which is going to be len a over b. So once more, you will end up having len 2. And you will get 2x plus 3, leading to the same result exactly like the first solution, which is going to be 2x equal to len 2 minus 3. That's x equal to len 2 minus 3 divided by 2. Most of the mistakes happen at this point. People talk len and then start moving the power outside. Okay? Clear? معايا شباب؟ Okay, perfect. طبعا you will have to review these problems. Maybe you have one of these. Here is asking you alternates, and it's a joke. You already have Logital, and you have a lot of knowledge. The only law that you may need that go above Logital is just to remember the law that I'm going to write to you right now. If I want to solve this problem, it's very, very simple. I can handle it with plenty of ways. But now you are we did go through Logital, so you can solve it just like that. So, first of all, this problem is made very simple. It's supposed to be a problem for everyone. Okay? So, if I want to solve this problem, simply it's going to be limit x tends to 0, and you have tan x over x. Once you start substituting, you will end up having 0 over 0, which is not a correct undefined value. So you can handle it a lot of ways. Let me go with the simplest one, and the talent and the tool that you have in your hand. Start getting Logital. I didn't tell you anything about how to solve this problem, so all the knowledge are with you. Start differentiating, but please differentiate in right way. Tan x, if you differentiate it, it's going to be 6 squared over x. Well done. It's done. Differentiating x, which is going to be 1, all you have to do is to do a direct substitution. Remember, if you don't know how to evaluate sec at 0, just remember sec is equal to 1 over cosine. So simply, it's going to be 1 over cosine square of x. This is the limit of x tends to 0. You will end up having 1. But also, you can solve it in another way. I can simply state that limit x tends to 0, it's going to equal to okay, sine of x divided by x times 1 over cosine x, which is very, very simple. All I had to do is to just break 10x to be sine x over cosine x. Getting sine x over x and moving just cosine x to the other side, taking limit x tends to 0. From the definition and from the previous laws, we already know that limit sine x over x will end up having 1 since the substitution is 0 over 0. Here, direct substitution, 1 over cosine 0, so it's going to be 1 over 1, and you will have the same result. Doing it like this or like that, both of them are handleable for you. The other problem, it's a little bit trickier. You can use logical, but you will need logarithmic use. But instead, we already know some wonderful limit x tends to whatever of 1 plus f of x to the power of g of x. If you start substituting and you have 1 plus 0 equal to the power of infinity, all you have to do is to get the limit of e limit x tends to whatever, same limit, but in this time you will have to multiply f of x times g of x and you will have the result of your limit. Please state the laws. If you could, in each time, try to state the law. I'm using logical energy. Once I have this, I'm using logical energy. So, in the worst case scenario, if you made a mistake down the road, I will have something to give you marks on it, and I've stated that plenty of times. Here, in a similar manner, it's going to be limit, which is x tends to pi over 2 for 1 plus cosine of x to the power of 3 sec of x. Once you start substituting, you will have 1 plus 0 to the power of infinity. The condition is satisfied, so simply it's going to be e to the power of limit x tends to pi over 2, start multiplying cosine x times 3 of a sec x, which is, without doing anything, it's going to be e to the power of 3. Simply, you will have cosine x will vanish with sec x. They will cancel each other. Okay? This problem is really very nice, and the use of this law is important. Otherwise, we can use logarithm, which is gonna flow everything related to limits. Logarithm is a very good tool in dealing with limits. Derivatives. The funny issue, some people make mistakes in such problems, although they have the main laws. If I start to look to the first function, and this is really, it's really very important, you will have to study all the main laws given to you in the derivative table. You will have to memorize them very well. Those laws are very important, as once we use these laws forward, you will get derivative in a few seconds. I will go to integration, and you will remember that I'm just doing the steps in a back way. Moving forward to get derivative, moving backward in order to get integration. So all you have to do is to please try to remember these laws, and also please try to write them down if you got a chance to do so. If I get for the first problem, start remembering that y, which equal to f of x related to a power of n, that means y dash, the first derivative for this function, it's going to be simply just n times f of x to the power of n minus 1 times f dash x. This is all you have to do. So the first problem will be simply y dash equal to 4 times 5, we'll end up having 20 over 4 minus 2 over x cubed to the power of 3, don't you forget, times the derivative of the function inside the bracket, which is simply going to be negative 6x to the power of 2. I'm done. If I made a mistake here, I will find this law, so it will help me out to grade it for you in your favor. If I come to the second problem, which is really also very important problem, the idea behind it, how to differentiate exponential functions, which is really also very simple. All you have to do is to remember that if I have y equal to e to a power of f of x, simply the derivative will be same function e to the power of f of x times f dash x. That's all you have to do. So, once we start differentiating, you will have y dash, which equal to same exponential function, e to the power of 4 of x power 3, plus 3 over x to the power of 2, plus 5. Then start differentiating the power, which is going to be 12x to the power of 2, plus 6x, and you are done. If I want to see the other problem, or the third problem, which is about a sign, about trigonometric functions, first of all, we will have y dash equal to, I will have to deal with, first, the trigonometric function, second, the argument of this trigonometric function. So simply, differentiating the n, it's going to be sec square the angle. The angle will be 2 over x squared minus 3 over x plus 2, then times, start differentiating the argument, which is that way you will end up having 4 over x minus 3. It's done. If I want to differentiate problem number y, okay, if I want to go through problem number y, I can do it using a lot of methods, but the simplest. Once you start to look into this problem, I have an exponential function here, but the base is a real number, and the power is just x times 10 of x. If you remember, this can be differentiated using 3 parts. So all I have to do, see and write it all down. I will start. Those are 3 functions. I will get the derivative of the first, time the two other parts, then differentiate the second, time the first and the third, then differentiate the last one. So, simply, y dash will equal to, I will start with the exponential part. How many parts? 3 of them. So, I will start 10 to the power of x of 10x times ln 10. This is the 2 parts from the exponential function. Then start differentiating the power, which is going to be 10x plus x times 6 squared x. This is the derivative of the first part. Don't forget, times sine x times sine minus 1x, then plus. I will repeat it. The first part will remain the same, which is simply going to be 10 to the power of x times 10x. Then I will differentiate the second part, which is simply going to be cosine x. Then the third part will remain the same, which is simply sine minus 1x plus. Similar manner, the first 2 parts will remain the same, so also we will have 10 to the power of x, 10x, then times sine x, but now I'm going to differentiate sine minus 1, which is simply 1 divided by the root of 1 minus x squared and done. Of course, it can be done using the arithmetic functions. If you take ln for both sides, you will have ln 10. Then start using the properties of the trigonometric function. It will separate it to be ln of 10 to the power of x plus 10x, then plus ln sine x, then plus ln let sine minus 1x, then start differentiating. Okay? Please do review this part. This is really very important, and it's an AB. You will have some problems about derivative in the final exam. Okay? Let's see the other problem. Okay, this is problem number 7, in which it's required to find the incident derivative for this problem, the implicit derivative, and also find a partial derivative for this problem. All of them are really very simple. A lot of students, unfortunately, didn't succeed in solving this problem in a correct manner. Although it's really very simple. All you have to do is to go in order. Dealing with a function in y, it's exactly like dealing with a function of x, but you will have to add y dash by the end of this problem. So, if we get to the first problem, it's going to be simply 2y dash for this part, which is y squared, plus 4 of x, then equal differentiating cosine, which is going to be simply negative sine. So you will have negative sine of x plus y. Don't you forget, this is going to be times the derivative of the angle or the argument, which is simply going to be 1 plus y dash. This is a successful derivative for this function. The second step is to isolate the parts with y dash. So all I have to do is to get negative sine x times plus y, once times 1, and then once times y dash. All we have to do is to rearrange also our problem. I will try to do it for the space as quick as possible. So I will have 2y dash will remain on this side. The other part will be negative sine x plus y times y dash. I will move it from the right to the left. So the sign will be plus, you will have sine of x plus y times y dash. Then will equal to. On the right hand side, you still have your negative sine of x plus